All right, so the instructions say rewrite the problem using a common denominator. These first 6 examples already have a common denominator, so we don't have to worry about that. Step 2, combine the numerators and keep the common denominator. So we don't do anything to the denominator. It's just like if we're adding 1/6 and 2/6, okay, what do? We add the numerators, we don't touch the 6 in the bottom. And then, after that, what do? We simplify, because we've got 3/6, so we simplify. So the same thing applies here. So example number 1, they have the same denominator. So all we have to do is combine their numerators. 13a plus 5a is 18a over 4a squared. We don't change the denominator. Then we simplify. 18 over 4, what can we do? Divide them both by 2, right? So 9 over 2. A over a squared, 2 minus 1 is 1. So we get an a in the denominator. That's it. That is it. Okay? Now, number 2. They have the same denominator, but you gotta be careful because it's now subtraction. So I'm going to take an extra step here, and I'm going to write the first numerator, and then I'm going to distribute that negative to my second numerator, because this is what people forget to do. They put the negative with the 7x, but they leave the 2 positive. Okay, but when you're subtracting that, you got to subtract the entire second numerator. So that means I change both the signs of the second numerator. Now I'm going to combine like terms. 9x minus 7x is 2x. 12 minus 2 is 10. Can I simplify? Because I can factor a 2 out of the numerator, and then I can I can simplify 2 over 16 and just be left with an 8 in the denominator. Okay, that's why we're able to simplify that one. All right, so let's look at number 3. Okay, we have the same denominators. We're adding, so let's combine like terms in the numerator. Y squared plus 10y plus 21 over y squared minus 9. Now, we need to see if we can simplify. What's the only way we're going to be able to simplify? If we can factor, right? We can't just cancel those y squares because those pluses and minuses. We've got to put this in factored form first. Y plus 3 times y plus 7. How about that denominator? What do we call that? Difference of perfect squares. We've got to recognize that, guys. Okay, we've got to recognize the difference of perfect squares. So now that it's in factored form, numerator and denominator, we can cancel the y plus 3's. So this simplifies down to y plus 7 over y minus 3. Now, let me show you a way you can check yourself. Okay, the way you can check yourself with any of these problems when they're simplifying and things like that. Go to your calculator. Okay, type in the original problem, the very original problem in y1, but you have to have parentheses around that entire numerator. So x squared plus 8x in parentheses divided by denominator in parentheses, bless you, x squared minus 9. Okay, plus second numerator in parentheses, 2y plus 21, close them, over parentheses, x squared minus 9. Put your answer in y2. Making sure you get parentheses around the numerator divided by parentheses around the denominator. What are we looking for after we get that in y1 and our answer in y2? Go to the table. We want all of our y values to match up. And they do. So that means they're the same. Okay? So this is a very simple way to check yourself to make sure that you did simplify it correctly. Now, it will not tell you whether it's fully simplified. Okay? So if I had typed in y squared plus 10y plus 21 over y squared minus 9, I would still get all the same y values, okay, because all that tells me is, yeah, you combine the numerators correctly. It does not guarantee that it's fully simplified, but at least I know they are equivalent, okay? So just throwing that out there. Let's look at number 4, okay, another subtraction problem, but there's only one term. So let's just go ahead and write that 1 minus 16a squared. Now, what do we not like about that numerator? It's not in standard form, and when we put it in standard form, it's a negative leading coefficient. So I'm going to change the order, and just to save myself some writing and space here, I'm going to go ahead and factor out that negative leading coefficient. Now, check it real quick. Distribute that negative back in there. Negative 16a squared plus 1. That's what I just had in the previous portion of the problem there. Okay? All right. Can we factor? Yeah. The top, difference of perfect squares. 4a plus 1 times 4a minus 1. Denominator, what do we factor? Take out a 3. 4a, don't forget that minus 1. Okay, don't leave that minus 1 out of there. So we can cancel the 4a minus 1s. Chances are they're going to distribute that negative in the numerator. So it's probably going to look like negative 4a minus 1. Okay, over 3. All right, couple more examples here with like bases, and then I'm going to let y'all practice for a minute. Okay, let's look at number 5. They have the same base. Let's go ahead and combine their numerators, or actually, hang on, it's got a minus. So I'm going to take an extra step and make sure I distribute that negative. Minus n minus 1. Now I know I'm going to have to do it eventually, so I'm going to go ahead and factor that denominator. Might as well, right? N plus 3 times n minus 2. Let's simplify the numerator. N squared, 3n minus n plus 2n, negative 7 minus 1, negative 8. Okay, so how does the numerator factor? N plus 4 times n minus 2. So the n minus 2's will cancel. We are left with n plus 4 over n plus 3. Okay, one more, number 6. Okay, we have the same denominators, so let's go ahead and combine, and it's plus, so let's just go ahead and combine like terms. 14k squared minus 7k. And let's just leave the denominator for this moment. Okay, what can we factor out of the numerator? 7k. So we're left with 2k minus 1. Guess what? I need to factor that denominator. I'm going to use the numerator as a hint. I'm going to see if 2k minus 1 is one of my factors. What is the other one? So if 2k times what gives me 6k squared? 3k. Negative 1 times what gives me positive 1? Negative 1. Let's check and see if it works out. 2k times 3k, 6k squared. We established that. We get negative 2k on the outside, negative 3k on the inside. Those combine to give us the negative 5k in the middle. So we're good. It does factor that way. It's not guaranteed, so you do need to check it, but it does work out in this case because the majority of the time, something's going to simplify on these problems. The majority of the time, something's going to simplify. So I just used something that was easy to factor, a GCF in the numerator, to help me factor something that could be a little tricky. Now, if you can look at that and factor it, go for it. Okay, that's great. But it does help you out to kind of use that as a hint if you get stuck. Okay?